This is kind of just an overview. This is what I normally talk about when kids are solving friction problems for the first time. So concept zero is that friction is a portion. The force of friction is some portion of your weight, right? So the weight is mg. And what we do is we multiply it by a coefficient. The coefficient is 0 to 1, right? So 0 would be frictionless. 1 would be you have to exert a force as big as the weight to slide it across a surface. And that's like, like rubber tennis shoes across a clean, gym floor would be close to 1. So anyway, that's concept 0, right? Now static friction is how much it sticks before it moves. So the force needed to break it free. So these kinds of questions are simple. You calculate it, right? You use the static coefficient, right? And it's always the bigger coefficient, okay? You calculate it, that's going to be some number, right? And if the applied force is bigger than that number, then it's going to break free. And if the applied force is less than that number, it won't break free. Okay, so it's up to that amount, basically, is the concept there. Okay, that's what static friction is. Now, kinetic or dynamic friction is a force that opposes the slide. And this is where it gets a little tricky, right? Okay, a force that opposes the slide. So we do it the same way. You're going to use the kinetic coefficient, the smaller coefficient, right, times m times g, and that's going to equal a number. And then this goes into our F equals ma formula, right? We've got plus or minus, I'll talk about this, some applied force, right, plus or minus the force of friction kinetic, right, is going to equal m times plus or minus a. So let's take a look at this. Okay, this is where it gets kind of interesting, right? Okay, so here's this block. It's on this surface, right? And let's say it's sliding to the right. And I always draw this, like if it's sliding to the right, I've got to draw this, right? Well, that force, that if it's sliding to the right, then that force of friction is going to be to the left, okay? The force of friction always opposes the slide, right? So we've got, basically our F equals ma looks like this. Some applied force, it's going to be plus or minus, right? And let's make plus is to the right. And you just read the problem, right? If the force is to the right, make it plus. If it's to the left, make it negative, okay? Okay. Plus or minus the force of friction, right? Well, this opposes the slide, okay? So in this case, I'm actually sliding to the right. So if I'm sliding right, then this is the friction is left. Okay, if I'm sliding to the right, friction is to the left. If I'm sliding left, then friction is to the right. It always opposes the slide. It doesn't oppose the applied force. They can be in the same direction. It just opposes the slide. Whichever way it's sliding, it's always opposite them, okay? And then that's going to equal m times plus or minus a. And here's where it matters if you know your positive and negative accelerations, right? Okay, plus or minus acceleration, right? So a positive acceleration is sliding right and going faster and faster. Or sliding left and going slower and slower. And you got to know this. Okay, that's a positive acceleration. You need to understand that that's what a positive acceleration is, because I'm not going to give you signs on the accelerations necessarily. You got to figure out the sign. Okay, a negative acceleration is, well, sliding left and going faster and faster. Or sliding right and going slower and slower. Either one of those is a negative acceleration, okay? people tend to focus on this bottom one here, right? Where you're going slower and slower, but a negative acceleration could also be going faster and faster. Okay, so what you need to do, step one in these problems is find the dynamic force of friction, or the kinetic, or whatever you want to do, right? Mu times m times g. And then read the problem. There's going to be an applied force, the friction force, so you can determine which way it's sliding. So if it's sliding right, friction is left or negative. And if it's sliding left, friction is to the right or positive. Okay? And then, depending on, probably then you're solving for the acceleration, but sometimes you're solving for this applied force. So then you have to look at the acceleration and decide, is it positive or is it negative? Okay? So take a look at those. Take a look at those problems. See if you can do the Quizlet problems, and then the next time I see you, we'll work through some of those. But see how far you can get. That's the main thing, right? See how far you can get with this, and the next time I see you, we can go through these things. One step at a time with the whole class. Anyway, good luck. Go get them.